In this video, we'll be talking about induction. What is induction and how do we prove things using inductive reasoning? So you're probably familiar with deductive reasoning, and deductive reasoning goes something like this. I start with a general argument and I end with a specific conclusion, all right? So deductive reasoning, we could start with something like this. All mangoes are fruits. It's a general statement. I can also make another general statement. All fruits have seeds. And statement 2 connects statement 1 and my conclusion. Therefore, mangoes have seeds. This is a specific conclusion. This way of reasoning is logically true and realistically true. This is the way that we've been using to prove things previously. Now, however, we're going to be using inductive reasoning. Inductive reasoning is the process of starting with a specific argument and then making a general conclusion. While this might be logically true, the conclusion or the conjecture or the proposition may or may not be true. So, for example, let's look at this mango example from an inductive reasoning point of view. So let's say statement 1, mango is a fruit. Okay, that's a specific statement about a mango. Statement 2, this box is full of fruits. Another specific statement. And it kind of connects, right? Kind of connects statement 1. And so your conclusion is, well, if mango's a fruit and the box is full of fruits, this box may or may not be full of mangoes. But we're going to conjecture or propose that it is full of mangoes. While this might be logically true, this realistically may or may not be true. Just before we get into an example of inductive reasoning, kind of to make it very simple, if I had this pattern 1 plus 2 plus 3 plus, and I ask you what number comes next, you would conjecture or propose that 4 is next. Based on the pattern that we see, the rule that's being applied, plus 1, we would propose that 4 is next. Now, as mathematicians, we can conjecture and propose this, but we cannot stop at just proposing it. We want to see that it's made true. So this lesson is kind of the intro to the point where we'll actually be able to prove what is next based on a conjecture or proposition that we have. For now, we'll just start with making a conjecture or a proposition about a pattern. So let's look at example number 1. Example number 1 says, by examining cases n equals 1, 2, 3, and 4, we want to make a conjecture or make a proposition or guess about what the sum of this sequence is. Guys, remember that the S stands for sum, and if it has a little n there, whatever the n is, that tells me how many terms I will add together. Okay. This is the general expression of those terms. So we'll start with n equals 1. Let n equals 1. And so my first term is simply 1 over 1 times 1 plus 1. Now, where did I get this 1 from? Where did I get this expression from? Well, I got it from right here. Okay, we're letting n be 1. That means we're looking at s sub 1. That means we're figuring out what is the sum of the first one term. Well, what's the first term? That's all we have to figure out. The first term is I sub I in, I equals 1. 1 I'm putting into the i's of this expression. Then I'm going to get my evaluate here. That's 1 over 1 times 2, which is 1 over 2. So this is my first term, but it's also the sum of my first terms. All right, so now we're going to do the sum of the first two terms. All right, n equals 2. Now, we know in this case that we're adding up the first terms, right? The first two terms. Well, I know that my first term is 1 over 2. Now, I just want to figure out what's my second term. Well, my second term, again, I'm using this expression, is 1 over 2, because we go to the next one. We know that the first one started with 1. The next one, you just substitute 2 into this expression. 2 plus 1. And that is equal to 1 over 2. So again, I'm just rewriting this. Plus 1 over 6. So I want the sum of my first two terms. Here's my first term, here's my second term. And the sum of those two terms is going to be, you can do that quickly in your head or off to the side, 2/3. All right? So I have my first term, my second term. So I need the sum of my first three terms. So n is equal to 3. So I'm just going to rewrite this again. So my first term was 1/2 plus my second term was 1/6. And now my third term is 1 over, this time I'm using 3, my third term. And you get 1 over 2 plus 1 over 6 plus, and that is 1 over 12. So this sums to 3 over 4. Last one, I want the sum of the first four terms, n equals 4. Well, I know that my first term was 1/2, my second term was 1/6, and that my third term here was 1/12. I'm going to add that to my fourth term. This time I use 4, and I get 1/2 plus 1/6 plus 1/12 plus 1 over 20. And that adds up to 4 over 5. Now we pause here for a second, because as a mathematician, we I hope maybe you notice a pattern that's going on here with the sums, the partial sums of each of these. Notice that my sum here is 1/2. My sum here in the first two terms is 2/3. My sum of the first three terms is 3/4. My sum of the first four terms is 4/5. So now we can make a conjecture about a pattern that we see. Conjecture about the sum. So we could say, we propose, or you could say conjecture that the sum of the first n terms will always be, and look at our pattern here. You can see that whatever term that we have, 1, 2, 3, 4, that's just going to be in the numerator. So that would be n, and then the denominator is just the numerator plus 1. So n plus 1. And then make sure you describe your variable, where n is an integer and it's a positive integer. So here's our conjecture. Again, this is like up here. We saw a pattern, 1, 2, 3. We're guessing, we're proposing that it's next. That's all we did. A little bit more complicated mathematical notation. Okay? All we're doing is conjecturing. We're just proposing what's going to happen next. That's where we'll stop today. That's where we'll stop for this lesson, proposing what will happen next. Inducting